Hello, my name is Wei. I'm presenting you my intermediate milestone number 1 for educational technology class. The name of my project is developing a PhET interactive simulation application for undergraduate developmental biology lab. So one motivation of starting this project is the fact that undergraduate biology labs are very expensive to run. Not only reagents and equipment are very expensive, but also it usually needs more than 2 teaching assistants for a typical lab with 24 students. Why are more teaching assistants are needed? One reason is the hypothesis-driven experiment design for biology labs. It is impossible to write customized lab menus for each group because each group has its own hypothesis and its own design, so that each group would have different issues and questions when designing and performing their experiment. I proposed here that simulation-based learning can prepare the students better for their experiment and so that reduce the cost of the experiment and the workload for TAs. The reason that I propose simulation-based learning as a solution is that students are highly motivated when they are under simulation-based learning strategy because they are in charge of what they are learning. Secondly, students have the chance to explore or test their hypotheses, which can improve their critical thinking ability. And lastly, simulation-based learning provides a near real learning environment. This would decrease the cost of education and increase the flexibility of education. In this project, I'm going to use the framework provided by PhET or PhET to develop a web application for an interactive simulation for an undergraduate developmental biology lab. PhET was founded by Nobel laureate Carl Wieman in 2002. It provides fun, free, interactive, research-based science and mathematics simulations. PhET is open source and it provides useful instruction and framework to design and implement a PhET simulation application. Currently, there are around 30 interactive simulations relating to biology lab on PhET website, but none of them is designed for an undergraduate developmental biology lab. So in this project, I will develop an interactive application for developmental biology lab. Basically, the interactive simulation that I'm going to develop should allow the students to simulate the development of a sea urchin embryo. Shown here is the high-level requirements that I gathered from the teaching assistants and the students. Firstly, it should allow the students to simulate their experiment to retrieve useful information based on their experiment design. Secondly, it should provide useful tools to help students prepare their experiment reagents. Last, it should allow the students to generate experiment report from the application. Out of these 3 requirements, the requirement A is the critical feature that the interactive simulation should have, so it is going to be what I'm going to focus on first. Shown in this slide is the user interface design. Basically, this web application will be a single-page application with several functional panels. Shown here is the control panel, which allows the user to either start a simulation or reset the simulation. Shown here is the experiment setup panel, which allows the user to set up their experiment based on their experiment design. For example, they can select which species of sea urchin to use, what is the salinity of seawater, what is the temperature for capturing, and if there's any drugs they want to test in their experiment. Shown here is the information panel, which shows the current experiment setup. Lastly, shown here is the simulation panel, which contains a dynamic picture of a sea urchin embryo and a timeline. After starting the simulation, the picture will move along the timeline at a constant speed. At each time point, the application will use its underlying logic to determine which sea urchin picture to show based on the current time point and the experiment setup. Shown here is the class design for this application. The DB simulation is the main class for the application, which manages the behavior of the application, such as start a capture, reset a simulation, and several utilities that allows the application to calculate the right picture to show, to generate lab report, and calculate the reagent recipe based on the experiment setup. The simulation stat class contains the statistics of the simulation, such as the URLs of all sea urchin pictures and the generated report and the reagent recipe. The experiment setup class contains all different settings of an experiment. This slide shows my test plan for developing this application. I will have unit tests for each method and class, and automate unit tests by using libraries such as Mocha, Chai, and C9. I will also have the integration test and system tests to make sure the application has the designed functionality. To sum up, in the first few weeks, I have finished the requirement gathering, designed the user interface, and have the class diagram ready and the test plan ready. In the next few weeks, I will focus on the implementation of both back-end and front-end of this application, and hopefully I can have a functional alpha version of the application for my second milestone report. Thank you very much for your attention. Please feel free to let me know if you have any advice, suggestions, and concerns. Thank you.